Alo, alo, alo. Alo, alo, ok.
Hello, good afternoon. So, okay. So maybe we can start with the Hugh, right?
Professor, I think this week I don't have anything to report because I just testing about the code and researching a fundamental. I think next week I
Okay,
will report.
okay, no problem. Okay, so then, okay, so from my screen, I can see Kong Mai.
Hi, Professor.
Yeah, so could you, do you have anything to explain, or
Uh,
I cannot find your Kong Mai here. Okay.
okay, wait. Uh, in last week I just study about the quantum Leerink and study about the quantum noise and quantum zero like
Okay.
like bit flip, XO and sorry, flip XO, and I have study about the quantum Leerink, uh the Schrodinger equation and the Hamilton.
Okay, so
So
your
just try to
so let me see so you added this quantum errors and so on, and
Yeah.
so the problem statement now.
I
Anything is
still
fine.
I still don't work on this section, so I will work on in the next week.
So what is the main difficulty on your side?
In I would like to reduce the quantum noise, and replace the quantum control in the process annually.
Yeah, okay. But annealing, how do you define your error model?
Uh, mm, Actually, I still I still don't study about it, so I will work on it on the next week.
Okay, so yeah, exactly. So this maybe I can point out. You can study many things, but it's important to define your program here.
Yeah, no.
Or error model. Okay, so yeah, you have to think about the errors that, sorry, this title here is, so yeah, so what are the error models in quantum annealing system? I think it's important.
No.
Okay. So the next one I can see 정선근. Okay.
Professor, can you hear me?
Yeah.
I'm writing the report. I'm currently studying my study. In the last class, professor gave me some comments. It is define what is my target variational quantum circuit, and the other is define the problem. So I defined my variational quantum circuit in figure 1. This is widely used in quantum neural networks. So in this circuit, I thought what is the quantum error occurred here. So in initial stage, maybe when we make the qubit, the initial, maybe the qubit preparation error can be occurred. And after that, when we apply the gate, when we conduct the gate computation, then the single qubit gate and two qubit gate error can be occurred. And after that, when we measure the qubit, then the measurement error can be occurred. So herein, I just defined the quantum circuit, and I just thought what is the error in here. And after that, in addition, my topic is feasible hybrid variational quantum circuits with quantum error mitigation. So I consider T1 and T2 time so when I study the T1 and T2 time, T2 time is more important than the T1 time. So herein, I study the T2 time is related to the circuit depth. So in this study, I fixed the circuit depth while considering the T2 time. And after that, currently I'm studying my problem statement with the error, which is initial state error and gate error and measurement error. And after that, I will model the noise considering these initial state error, gate error, and measurement error.
Okay, so here at the moment, you are collecting all of the information about variational quantum circuit and quantum errors and problem statement is not yet stated.
Yes, right. I'm studying and I'm writing the problem statement here.
Okay, yeah. And the next one I can see 정상근, 공마이, Hugh, and Kim Jae-wan.
Yes. My report structure would be like, I want to start with the maximal secure key, and I want to prove that the maximal secure key forces the quantum state to be a private state, and thus it indicates that the ideal state for the distribution of quantum key is private state. So, and the private state, I want to show that there are two properties for the state, and two properties characterizes errors in QKD. So in my thought, the quantum errors in QKD might be the errors in the information between LHC and Bob, and eavesdropper's knowledge about the LHC's information. And to deal with these errors, I think there are two ways to compensate errors. One is quantum operations, and the other one is classical post-processing. And that's, that's all I thought about.
Okay, so here, still, I mean, problem statement is not clear.
Yeah.
And before that, I mean, here is a maximal secure key. And these things, maybe you have to explain all these before problem statement. So before problem statement, you have to provide all of the information about the background and motivation here. And
Yes.
using terminologies here, you can define the problem statement and explain the quantum errors in the scenario and present how to deal with the errors here.
Okay.
Okay, I think, okay, the last one, maybe Ho Ji-won.
Yeah. I try to compute the smallest component of input state at occurs. I wrote my result in 3.b. However, I wanna add the computation procedure in appendix, but I didn't do this yet. So I will add the total computation procedure, and I will add some contents to preliminary and extra.
Okay, so problem statement. So reference 4, what is it? Compare complexity of exterior products, multiply test, and non-tracking. Okay. I suggest, I mean, this document must be self-contained. So you have to provide, I suggest you provide information about, say, fermionic sampling and so on, and they are all in this preliminary and background, and define the quantum errors. And also, yeah, here, you can cite this one. Okay, you can mention reference 4. You should mention, but you should be detailed in the explanation about the background. It's not a research article. It's a report, okay, project report. And Yeah, and the problem statement is not yet done, but yeah, but you want to do in the future, right?
Yeah.
Okay. Any
Thank you,
questions?
Professor.
Okay. Any questions? Or so while you work on your project, do you have any questions or?
Yes, Professor, can I have a question?
Yeah.
I'm studying the state preparation error in superconducting quantum computer, but it is a little bit difficult to me because it is related to the physical information. So can you recommend some papers to study this one?
Okay, so my suggestion is do not study, is my suggestion. So first, clarify your objective. So what do you want to do here? You want to be expert of superconducting qubit?
Yes, right.
No. So do you want to be an expert of superconducting qubit?
Actually, in my study, I cannot manage the generating the qubit. So, but when I conduct my variational quantum circuit, there is a state preparation error. So I think I should consider this error, but I'm not sure what is a good error model is in this state preparation error. So currently I just studying the physical operation in superconducting quantum computer.
So if you know everything about superconducting qubit, then do you think you will know, you can characterize the state preparation error?
Yes, Professor.
No, I don't think so. So there are many ways to prepare a quantum state, not just a superconducting qubit. So it's a different questions. You are mixing two questions, and you will not get the solution. So my comment, clarify your objective, your question, okay, and think about these possible answers, approaches. And like now, okay, so what is your goal? Can you clarify your goal again, your objective?
Yes, Professor. Simply, I want to design the feasible variational quantum circuits which can be implemented in this disk device. Disk device is a superconducting based quantum computer. So
Yeah, but disk is not only superconducting qubit. So what you're saying is not so precise. So if you're precise about what you're saying, and there is then I think so please try to be precise what you know, and also please open what you don't know, clarify what you don't know. Okay. So your objective here is what? Is
actually, I don't know how to make the qubit in superconducting quantum computer. And after that, if the qubit is generated, I don't know what is the error in the state preparation.
Yeah. So there are many things you don't know. Okay.
Yes.
So I'm saying that what is your objective?
My objective is to mitigate the error in this variational quantum circuit. So I divided the quantum error threefold. One is state preparation error, and the gate error, and the measurement error. in the case of the gate error and measurement error, I can study using some papers, but I don't know well about the stage percussion error.
So these errors depends on the physical systems. You cannot specify this as a superconducting qubit. So there is a discrepancy in your approach and in your question. So even if you take this kind of approach, you will not reach the solution you want to have.
In this case, can I assume that the state perturbation error is not here?
But do you understand what I'm saying? Do you understand what I'm saying?
Yes, a little bit, Professor, but I'm not sure, Professor.
So if you don't understand, I mean, what is the point of saying this? So you have your question. Now you are taking an approach to solve the problem. So I'm saying that even if you take this approach, you will not get the answer for your problem.
But I'll try to my best to find some good approach here.
So now is again I'm saying even if you try your best, even if you do your best, this approach doesn't tell you the solution in the end. So I want to go to New York, but I'm trying my best to go to Paris. I'm not getting New York in the end. And this is exactly what you are doing now.
Yeah, I just think now maybe I should assume or I should make my scenario first clarification.
So you want to mitigate errors in VQE in a quantum circuit, and now your approach to that problem, you want to understand errors in superconducting qubit. And in this way, you cannot deal with the errors in variational quantum circuit. So there's a discrepancy in your approach and the question. And this is what I can point out at the moment.
Yes, Professor, I will consider it with more time. Professor, thank you.
Yeah, think about it and tell me more next time, okay? For questions, okay. Other questions or comment? So any help you need from my side? Okay, so again, I mean, this is the course. You have to think about the project and focus on the project, okay? But any help or questions, let me know, we can discuss. And also so all of you still need more time to define your problem, okay? And we can meet in a week, next week, this time, 4 p.m. So when is that? It's a 28th of March, right? Sorry, 31st of March. Okay, so have a nice week. Then I will see you next week. Okay? Monday next week. Okay, let me close. Bye bye.